In this video, we'll tell you all about the Project March input device. We'll explain how the device was created in collaboration with our pilot, how it works, and we'll even show you how the input device is used in action. But first, let's talk about co-creation. We use this concept a lot when we talk about how we design our exoskeleton, and especially our input device. In a business context, co-creation means that the opinion of consumers is essential in the design of a product. That's also how co-creation takes place at Project March. The opinion of our consumer, or pilot, is used throughout our entire design process. But why do we think this is so important? Well, in the end, the pilot knows best what will work for them and what will not. Any aspect of the exoskeleton is custom made to their preferences, so that it ultimately becomes an exoskeleton they like. Some aspects which we specifically co-create with our pilot are the fixtures, the appearance, and the input device. The fixtures are not only made to fit their body, but we also ask the pilot if they are easy to use. The same goes for the appearance of the exoskeleton. We want it to look reliable and visually appealing to the pilot. This is also a reason why we pay a lot of attention to the exterior design of our exoskeleton and add, for instance, color details. And then there is the input device. This is how the pilot will control the exoskeleton. So it's important that they find it easy to use. At Project March, we have worked with several different pilots. And for each of them, we have custom designed an input device. Through the years, we've also considered several different options for providing input. And in the future, we would like to see an exoskeleton where the pilot doesn't need to use crutches. Without crutches, an input device in the crutches would no longer be ideal. Therefore, we are constantly looking for new ways to make giving input faster and more intuitive. But right now, we need an input method which is easy to learn to use, reliable during a competition, and also fast to use. So we have kept the input device integrated in the crutches. Now, the process of co-creating an input device consists of several phases. In the first phase, we research our user and existing products. We also interview the users and experts on the subject. From this information, we set out our requirements and in the second phase. Then in the third phase, we brainstorm different ideas, develop these into concepts, and ultimately decide on one. Then there are two more phases. After having decided on a concept for the input device, we make a mock-up for this concept and test this both with team members and our pilots. The feedback from these tests is then used to improve the model, so it's ready for the final phase, which is production. Now we present all of these phases as if they are linear. However, during these phases, you may jump back and forth between phases, going back to your requirements or revisiting your first concepts. In this course, we've already researched our pilot, and in this week, we've also already looked at existing products. So we are now in the second phase. We are ready to set the requirements for our input device. Now, there are a lot of small requirements for an input device, but the following three are the most important ones. The device should allow the pilot to control the states of the exoskeleton. It should be easy to use, and it should also be safe to use. We have used these requirements to create our input device, and we use the opinion from our pilots. For instance, how about how large the handle should be? What kind of images each gate should have? Or what buttons we should use? Now let's talk about the different components which make up our input device. The first part you notice when you see it for the first time are the crutch and the handle. The crutch is a basic crutch you can buy anywhere, and we adapted this one. It now contains a small basket with some electronics in it and a USB cable which connects the input device with the exoskeleton. This ensures that data can travel between the exoskeleton and the input device. The input device also receives its power from the exoskeleton via the USB cable. And then there is the handle. This part has been made to fit the hand of our pilot perfectly, by first creating a clay mold which our pilot could grasp for easier fitting. The handle also contains a display screen and several buttons. The display screen is not a touchscreen where the pilot can provide input, but it visualizes the different input options. It shows the gate selection menu where the pilot can see which gate they can select and is selected. Here, each gate has their own symbol, which was decided upon together with the pilot. Then there are several different buttons, each with their own specific function. There's the rotary encoder. This is a scroll button with a click function. This button is used for scrolling and then selecting in the gate menu. In this menu, the pilot can select all the different gates. The push button is a shortcut to the gates for walking and the single step. This is kind of a mini menu, so that the pilot can quickly get up and walk. Then the rocker switch can be used to change the size of the steps. The size of the steps can be made bigger or smaller by rocking the switch. The final button is a trigger button on the back of the handle. It's an extra safety feature, which can be used in two ways. First, it must be pressed to confirm the gate a pilot has selected. And then it can also be pressed during a gate if a pilot wishes to stop the gate while it's happening. The exoskeleton will then move towards a safe standing position. The last aspect of the input device, which we'll cover in this video, is the vibration motor that's integrated into the handle. If the pilot confirms a gate, this motor will vibrate, thus providing feedback to the pilot that the gate is going to start. We'll talk more about feedback from the exoskeleton in a later video.